All right, we are in Algebra 1. Today's date is Friday, March 15th. March 15th. What's going on here? Oh, man, I was late. All right, I'll change it in a sec. March 15th.
Who gets the XP?
I'll figure it out later.
No,
All right, so square roots. This symbol right here. This symbol right here, it has a very specific name. Who knows the name of this?
Square root.
It is also a square root, yes, but it has a very specific name.
It's that line with like zoom
No.
What's your heart rate?
Write it down. It's called a radical. Radical, man. That's how you pronounce it, radical. So if I ever say radical 25, like I see down here, that just means I'm saying the square root of 25. So radical 25. That's how I could pronounce this thing. I could say square root of 25. All right. It has a very specific meaning. You guys probably already know this, but in a relationship, I need to get you set up for cube roots as well. So it means that something... And when I say something, I really mean some number, but something times that same something equals the number. That is the algebraic way of saying it. All right, so it also has a geometric meaning. I don't know how many of us know the geometric meaning. Why do we even call this thing a square? It's because it comes from a square. So if you go ahead and sketch a square, there's my sketch of a square. What this square root of 25 down here means is I have an area of 25 units. What is the side length? So the question mark, what are the side lengths, assuming that that is a square? We have a very interesting definition for a cube root as well. All right, so square root of 25. What is the answer for square root of 25? Quiet raised hand. Easy peasy, Monse. 5. And just showing you guys what we're doing with the definition. Our definition means something times something equals a number, which means if I didn't know what the square root of 25 was, I could do 25 and do a factor tree. What times what is 25? And Monse already told us 5 times 5. Those are the factors. And we have two groups. Write it down. I know it seems simple, but it will help us when we start doing cube roots. There are two groups here. Two groups. In the first group, we have 5. In the second group, we have 5. First group, second group. So far, so good? All right. So Monse got her XP. Let's come back and give her XP. And then example 2. Square root of 144 is... Jenny?
12.
Is 12. I need someone else to do a factor tree for 144. Someone do a factor tree for 144. Who's going to do it for us? Go for it, Josie. 12 times 12? Yes. But what if you didn't know if it was 12 times 12? What are the factors of 12 and 12, Josie? 3 times 4, and this one is also 3 times 4. And then factors of 4... 2 times 2. Oops, got something like there. 2 times 2. This factor 4 is 2 times 2. So our factor tree really can be rewritten as 2 to the power of 4 times 3 to the power of 2. That's how we factor. We count all the 2's. How many 2's do we have? 1, 2, 3, 4. 2 to the power of 4. How many 3's do we have? 1, 2, 3 to the power of 2. From there, I need to separate this into into two groups. We're not doing cube roots yet. So I still need two groups. So here's my first group. 2 to the power of 2 times 3 to the power of 1. That's my first group. My second group is 2 to the power of 2 times 3 to the power of 1. That is my second group. The reason that this answer is 12, I mean, it's something that you can just memorize, but it's 2 to the power of 2, which is 4. 4 times 3 is 12. This group right here is 12. Since I made sure that both these groups are the same, the answer is this group, which is 12. That also means if I had a square that had an area of 144, the side length of that square would be 12. All right, fist of 5, how well are you following me? 5 is I got it. Mr. Sindel, I'm ready. All right, I'm seeing mostly 4s and 5s. We're on to cube roots. This is hopefully still review, but maybe a little bit harder, maybe new for some people, we'll see. All right, so cube roots. What do I read this as? So this number right here, this 3, is called something very specific. It's called the index. Not Windex, but index. I undid too far. This is called the index. And then, of course, we have this radical symbol, so we can label that as well. This symbol right here is called the radical. And the number in here is technically called the radicand. Radicand. I won't ever use this word radicand. I am still not used to saying it, but I'll definitely be talking about the index. So if there's anything that needs to be starred, it's the index. If we were talking about a square root problem, let's go back up here to the square root of 25. That's a good example. Go ahead and draw square root of 25 nice and big over here. Even though there's no number, there's no index for the square root of 25, it really does have an index. It's a hidden index. The hidden index is 2. So we can say that 2 is hidden. So whenever you don't see an index, assume the index is 2. Assume it's a square root. This will be helping us in Monday's lesson, our next lesson, when I start doing fractional powers. All right. Coming back to cube roots. So this cube root of 8. Cube root of anything. What does that mean? It's very similar to our square root. Our square root was something times something equals that radicand. This one is almost the same. Now there are 3 groups here. It's something times that same something times that same something yet again. And notice here that there are 3 groups. We'll make that note down here. There are 3 groups instead of 2. So, very similar to example number 2 and example number 1, I'm going to do a factor tree for 64, and when I get all the factors, I'm going to separate them into 3 groups. This is the fail-safe method of always getting the cube root. If you don't know how to get a cube root because it's a giant number, do a factor tree and then make 3 groups of the factors. You will always get the cube root. Of course, you could just memorize what the cube root of 64 is, but you might not always know. All right, so cube root of 64. Let's go ahead and make a factor tree. I need help. Who can help me do the factor tree? Quiet raised hand. Who's good at factor trees? Do you have your cards still, Josie? Yeah. Didn't I call on you? Oh, wait. One thing? You. All right. I want to give it to someone that still has a card. But Josie's our backup. Jenny, do you still have your card? No. Jenny's also a good backup. I need someone that still has their card. Who can do a factor tree for 64? Yeah, Cohen, go for it. 8 times 8. 8 times 8. And you might be thinking to yourselves, that would be, like if I had the square root of 64, the answer would have been 8. But somehow I need to get this into 3 groups, so that's why we have to do a factor tree. Cohen, 8 times 8, or what is the factor of 8? 4 times 2, and 4 is? 2 times 2. And I'm going to do the same thing on this side as well. It's the same factors, 2 and 4 is 2 and 2. All right, there are only factors of 2 here. So we don't have 3, we don't have 7, we don't have other prime numbers, we just have 2. And Cohen, how many do we have? 6. We had 2 to the power of 6. So when we made our factor tree, our prime factorization is just 2 to the power of 6. Somehow I need to divide 2 to the power of 6 in order to get it into 3 different groups. Thank you, Cohen. Someone else. get 2 to the power of 6 into 3 different groups. Again, 2 to the power of 6, if you don't like looking at 2 to the power of 6, you want to see it this other form, you can say 2 times 2 times 2, that's 3, 4, 5, and 6. You have 6 2's. So I need to make 3 groups instead of 2 groups. How do I make 3 groups? Does someone see what it is? Fernando?
The 2 to the power 2 3 times.
Okay, so this is 2 to the power of 2, and you do that 3 times. There are our 3 groups. Each of them is 2 to the power of 2, so they're all equal. You have to make sure your groups are equal because it has to be the same something times the same something times the same something. And Fernando, 2 to the power of 2 is 4. The cube root of 64 is 4. That's something that I would highly recommend memorizing. All right, that's all I have to teach you about cube roots, but I do want to give you a table of all the squares and all the cube roots, the square roots and cube roots that you need to know for the homework, and I'll talk about the ones that you really need to memorize for the rest of your math career. All right, the square root of what is 3? Shout them out. Square root of what is 3? Or, yes. Another way of asking that is 3 squared is what? All right, so Cohen got some more XP. Who did I miss also? Fernando, right? Fernando has his card in. All right, square root of what is 4? Andres? 16. Write it down. The square root of 16. And if you ever get lost, there is a table up above the overhead that has square roots and squares. You can literally read them off to get some XP. Square root of 5, or square root of what is 5? Sergio?
25.
25. Write it down. Sergio got some XP. He got his card in. Square root of what is 6? Monse? 36. Monse got some more XP. Square root of what is 7? Eder? 49. Write it down. Make sure you have it in your table. Square root of what is 64? Or, oops, I gave it away. Square root of 8. Square root of 64 is 8. I don't know what I'm doing. I'm going backwards. Well, square root of what is 9? That's the correct way of asking it. Josie. 81. Square root of what is 10? Jenny? Next, we're doing square root of what is 11? Sergio, go for it.
So 110.
Ooh, careful. Not 110. We'll give it to Andres. 121. So Fernando's.
Do I get double XP since you didn't give me the first time I did it? Like, what do you mean? You didn't give me XP? Oh, the first time I did it.
I didn't?
No.
Okay. And square root of what is 12? Fernando. 144. All right, literally memorize this entire list for square roots. You don't need to memorize the entire list for cube roots, but you do need to memorize them for square roots because you will be using all the way up through 12 for a while. All right, and then Fernando just did this last one. All right, let's go through it for cube roots. Those are not up on the board, so they're going to be a little bit harder. All right, we just did 4. What was the cube root of what was 4? Josie? 64. That was our example problem. Thank you, Josie. All right. Cube root of what is 3? Another way of asking this is, what is 3 times 3 times 3? I have 3 groups of 3. 3 times 3 times 3 is? I'm looking for a quiet raised hand. Cohen. 27. Thank you, Cohen. Five times 5 times 5, or the cube root of what is 5? Cube root of...
25.
Yeah, Sergio, say it again.
125.
125. There it is. All right, these are the ones that you need to have memorized. These. Memorize. You will need those for the rest of your math career. These ones are less familiar. All right, I'll still give XP out though. If you can get them 6 times 6 times 6, you can use a calculator if you would like. We'll get through it nice and fast. You guys can pull out your phones. 6 times 6 times 6, Andres?
216.
216. There it is. That is so the cube root of 216 is 6. Andres got in. 7 times 7 times 7, Fernando. 343. 8 times 8 times 8, Cohen. 512. Let me come back here. Got Cohen. Got Fernando. 9 times 9 times 9, Andres.
729.
729. Got Andres. Did not forget him this time. All right, this one is an easy one. 10 times 10 times 10, Sergio. 1,000. Notice that there are 3 zeros because it is to the power of 3. All right, Sergio got some XP. Fernando, next one. 1331 is indeed. The cube root of 1331 is 11. And our last, and what I think this is the hardest one, Andres?
1728.
1728. All right, those ones you don't have to memorize. I don't even have those memorized. I roughly know 6 and 7. I definitely don't know. Actually, I do know 8 because that's an easy one. But 9 through 12, I don't have those memorized. Although 10 is easy. I guess I have this mostly memorized. 9, 11, and 12, I don't have memorized. But you guys are responsible for memorizing 0 through 5. That is it for the lesson. And that is our homework. We have cube roots and square roots. A question for your homework might be, what is the cube root of 343? You will type in 7. That concludes today's lesson.